We have our next presentation now by Praburam and Rajendra Kumar. They would be talking about enabling quality and source. Thank. Over to you guys.
Good morning, everybody. Thank you, STC conference, for giving us an opportunity to present our white paper and idea over here, enabling quality at source. We are going to, me and Prabhu are going to present enabling quality at source. We are really happy and delighted to attend this conference and hear many presenter presenting on various aspects of quality and the software engineering processes and best practices and innovations. Myself, Rajendra Kumar, having around 25 years of experience in software design, development, and architecture. Currently, I'm working as an application architect at CGI in products. My colleague, Prabhu, over to you.
Thank you, Rajendra. Good morning, all of you. I'm Praburam, working as a technical architect for CGI products. Overall, I have 20 years of experience in the software industry. Over to you, Rajendra.
Okay, thank you. So, enabling quality at source, what it is. Yesterday and today, many presenters presented about how to what you say prevent defect leaking into production using AI ML technique, how shift left approach work, how the quality initiative, and how to use another modern techniques, technologies, and best practices and all. So our presentation or the white paper in line with all these ideas, and it is going to be one among one of those ideas, augmenting whatever other speakers have already presented. So now the what is the business need and challenge we are trying to address here? When we say enabling quality at source, the first and foremost thing is cost of quality. In the complex world of software engineering, the products are facing lot many issues due to issues or defects seeping into fag end of another development life cycle, which are very hard to fix, or sometimes it results in customer dissatisfaction as it gets into production area. And how to address that? This is another one of the big challenges, the prime challenges. How to make sure that defect detection happens very early on in the development life cycle, and we have a good amount of control over that. The second aspect is our current tool chain set, right? We have CI, CD, and a lot many other things in place. There is the gap between our current tool set and CI, CD, and sometimes the current tool set may not complement continuous integration and continuous delivery. How we are going to address that challenge. The third aspect is we all the projects and products and software engineering use the lot many in the SAST and DAS tools, and the results from these tools and turnaround time on analyzing and addressing these issues will have an impact on the schedule, especially if some critical stuff are discovered at the later stage in the development. The last one is another approach, basically analyzing all these results from the static code or the DAST or the other means by developer community, and coming up with a root cause analysis and coming up with solution and implementing that will have a longer turnaround time, and it will have an impact on the product deliverables or the quality of software which we are delivering. So now this is the challenge or the problem. We when we analyzed, we put into four categories. Now what approach we took to address these challenges, and how we come up with the ideation. So approach we took in our organization is, first we brainstorm with all the stakeholders and SMEs. We put all the challenges and problems from the previous slide and many more into this group to brainstorm and come up with ideas, suggestions, solutions, and what probables and what can be done. That is one aspect. We explored already available tool sets, COTS, off the shelf tools, how much they can be used to address the challenges which we are facing. And then we evaluated the alternate tools also to see how we can better utilize them to address our challenges. With all these three steps done, we came to the ideation phase where we involved the community of practice as well as the developer community to come up with an idea or an ideation with the following constraints, where whatever we try to put together, it should address the larger technology stacks. Predominantly it is Java, .NET, Python, etc. And it should enable developers during coding, because whenever we do the most of the analysis, it will end up in the code. The problem is in the code, because all the requirements or the testing will point to that effect in the code. Okay, so the other aspect we look was, it should not be outside the existing SDLC. Means it should not be any other process burden onto the developer community. Sorry. So it should augment or it should gel well with the existing tool set is the one of the criterions. The other one is it should not add the extra cost to the development project. And no third party dependency is one of the predominant things, as far as possible. If we are able to do it within our organization, within our organizational structure and the development community, that would be good. And the tool or the technique which we are going to come up with, it should be flexible, it should be configurable, and it should be in line with the coding standards and the things which we follow at organization. This is the approach we took. Now the solution levers which we considered, which are, first one is the shift left approach. Many speakers from the yesterday's keynotes till the today morning and just a prior session, it was always the shift left. What shift left means? Basically, the issue or the problem should not be in the post release or during the testing or in the integration. We should try to find as many issues as possible during the coding itself, so as to make sure that whatever has been coded, it is in accordance with the requirement specification, and it should be fully compliant with all the testing and test coverage, everything, and the end customer expectation. That is one of the solution levers we considered. The second one is the quality. We want to move from quality assurance to quality engineering. A morning keynote speaker from our organization, Kavita, has presented on this. And quality assurance is basically after effect, after coding, when the thing will get propagated into upstream environment. There the various tests happen, and we find that there are issues. And then it comes back to development, and the cycle continues. We wanted to move, that was quality assurance. We wanted to move to quality engineering. That means every piece of thing which we do in every stage should have the quality gate, and it should adhere to that quality gate and pass through it, so as to minimize the issues popping up in later stages. The last but not the least is the community of practice. We have various communities of the practice with the stakeholders from all parts of the software development life cycle. Okay, so we presented our idea to communities of the practice. We got their feedback, their criticism, their their feedback, and we went ahead with implementing our solution. Once the solution was ready, we again went back to another community of practice to check, verify, and get their feedback whether it is in line. It can go, it can be taken to larger audience and things like that. And once it is accepted, this is the community of practice is a one which will percolate down the solution which we have come up with to all the groups, projects, and products. So now coming to the high level overview of what the solution we are proposing and how it is going to help us. It is in this slide. The center part of this presentation, basically you see CPU with another cloud image in there. That is basically the centralized scanner. Okay, it is deployed in the cloud, and all the applications are scanned through this the cloud-based system. Okay, and what we thought was the best place to implement the solution is they have a plugin onto this box or this cloud deployment. And what it does is every instance of the application which are going to be done as static scan will go through this plugin configuration. It will identify the issues, and they will be available to the developer community. Okay, that is one part. On the right side, this cloud-based deployment will generate health dashboards, health monitoring, and the other analytics, which is for the stakeholders like managements, basically project management, engagement management, and business excellence or SQA, the teams, and so and so forth. It will give them a clear picture on how things are going, and where we are heading with respect to the product quality and various measuring parameters. The next is the detailed overview when this solution applies to an individual project or the team. Individual project or the team have nightly scans, SAST scans happening. Okay, that is on the rightmost top corner box, and where the plugin is there. And then in the integrated development environment, we put together here the Visual Studio and Eclipse as the development tools and source code repository, whether it is Git, SVN, or whatsoever. From the application instance central box, the plugin will percolate down to individual developer IDE, and developer, as and when they code, the plugin will come into effect, will check whether they are writing right code or there are issues or problems or violations. It will be in the real runtime, and as it happens, the developer will get to know there is a violation. They can look at the help in there, and then they can address and fix it and eliminate it. Okay, and for the stakeholders, especially for the project monitors who are looking into the quality aspects and nightly scan results, etc., a dashboard and analytics will be there. For some reason, if developer misses, the next day the people who are looking into the quality aspect of the respective project, they can look into dashboard and analytics and notify the respective developers who has coded bad or who has checked in something which is not supposed to be. The turnaround time is just 1 day or 1 or 2 days. It is the instant in case of a developer. It is a day in case of a project team. So that's how we can minimize the problems and issues or customer issues getting into the upstream areas. So now how all these things will work. I will request my colleague Prabhu to present the demo. Prabhu, over to you.
Yeah, can you hear me?
Yeah.
Okay. Okay, before show the demo, I will just quickly give you a heads up how the demo looks like. The coming slide will be using a Visual Studio. The .NET developers typically use that, right? So this plugin will monitor the code as developers write, as Rajendra explained before. And then it will immediately highlight wherever there is a code that is going to breach the standards that we set. And then it will give you some detail, and they can fix it. That will go away, and they can also scan. And they also scan the issues of the entire source code. I think we think this is saving a lot of time for the developers and also the other technical leads for the project. So Rajendra, can you? Okay, next is animated GIF, as a 10-second long, and there will be some subtext as well to tell you what is actually happening under the editor. So it will be a self-explanatory, I believe. So let's see how it looks. Rajendra, can you please click next?
Yeah, Prabhu.
Yeah. this is the very short clip. It's actually no, it is in a loop, so it will keep running. So basically, start writing the code. See, as you see in the GIF file, so immediately just getting that, this issues pops up, and the developer has an option to check that out, and they can fix it. And this is for the currently editing files. And we can also run by default. This plugin will not scan the whole code of the solution. If they do, then it will affect the performance. So it will focus primarily on what is the code modified by the developer. And then if I want to know the entire violations on the whole solution, I can go run this plugin on the whole solution. So this way it's pretty quick. The developer does not need to go away from his or her IDE to see the violations. Yeah, Rajendra, can you please talk about those benefits in the next slide?
Yeah. Thank you, Prabhu. Thank you. So now we will move on to the benefits of the solution we put together. The tangible part, we have seen a reduction of technical debt to up to around 24% in a year in the products which we have used this, and we have seen a productivity improvement of around 18 to 20%. It has reduced around 16% of the client incidents. Post production incidents were down by 16% in the places where we have used. As it is as this is our own tool, it doesn't have any license cost, and the cost of development of the plugin or the solution is minimal, because we used our own developer community in a crowdsourced way to come up with this plugin. And we keep continuing and adding the challenges and the problems, solution for the problems into this plugin idea. And we keep expanding it, and we keep expanding it into other teams. That is on the tangible part. On intangible part, the first is the quality at source is another big benefit. Error detection while coding, it is real time and instantaneous. It helped us prevent most of the issues which otherwise would have gone into the source code. The second is the continuous integration will find the issues if at all it missed by the developer during development. And also there are more room for additional regression cycle. I will explain this a bit. Earlier, our regression cycle, okay, used we used to it used to take 5.5 days to complete a regression cycle. So with this approach and the this ideation implementing, we have reduced that from 5.5 days to 4.5 days. That means in the same period of 5.5 days, we can run the additional regression cycle. This is an intangible benefit which we have seen. And this solution has improved the agility, because it is the developer friendly. It integrates with the existing SDLC without any additional process or outside that, and helped remediating issues immediately, and it helped improving the the knowledge of the developers. And it reduced another analysis by another effort by another stakeholder, especially if there are issues, it can be easily identifiable with this. And flexible and configurable is something I would say we can make this plugin as another very strict and rigid, so that developers will not be able to check in the code until they fix all the issues and block them there. In some instances, we use that, and in some cases, we made these issues are very high and the critical, so that it catches. It will be caught by the quality gatekeepers of respective projects and teams. This is how these are another benefit. And before I conclude, I would like to add another customer perspective of wherever we have implemented this solution. We have seen improvement in the customer satisfaction by around 60 basis point, from 9 to 9.6. That we have an internal measure with our customer, which we regularly connect with the customers to take their feedback about our services offerings, innovation and quality, etc. That is one point. The second point is the existing customer where we have implemented this solution, they were happy because their post production issues have come down, and we involved them from the beginning. We kept them in the loop with respect to our initiative, what we are doing, how it is going to benefit them. And that has helped us to win their trust and confidence. And when we deliver the results, that is the testimony for that. And the customers were happy, and we got more sites for our products and offerings to be expanded at existing customers. The second benefit is we got the new customer wins because of the testimony from the existing customers, and this enabling quality at source along with the other initiative has helped us to gain that confidence, and which resulted in the new wins for us. So that's pretty much from our side about enabling quality at source. And I sincerely thank organizers of this conference for giving us a forum to present our white paper and talk about it and our idea. I really appreciate. Thank you